So we've looked at the internet-facing side of the device, we've looked at the local connections. Now we're going to go right into the heart of the product, and we're back with Ika again. So Ika, what is the kind of activities that go on here when you're actually breaking into the product itself?
Well, that's actually one of the most overlooked parts of the security, I would say, which is the everything affecting the local electronic components of the device that we analyze extensively here.
So what is it you're actually looking for then when you...
We look at many things, but we mainly focus on two areas. First is we try to find any local storage present on the device, and we try to extract those chips and read them.
So this is data then actually stored on chips on the device?
Yeah,
Okay.
It's not, I wouldn't say it's common, but some devices have sensitive data stored that an attacker can extract. And the key thing here is that sometimes this data is universal in the sense that it can be used in similar devices that you have not accessed.
This is something I suppose that people might not realize, that then an attacker could, I presume, buy one of these off eBay.
Exactly.
Or steal one of these devices, open it up, read the information in there, and from that be able to attack everything.
Yeah, you could.
All other devices,
massive
across the
scale
internet.
attack can start with something like that.
Okay, you mentioned two things. I can see a load of wires hanging off.
Yeah, the second thing is that we are actually testing that. Many of the PCBs or the electronic components have left some pinouts that are used for design of the electronic components, where are in fact electronic interfaces. We try to connect through serial methods to those interfaces and see that if we can speak directly with the processor.
You now then bypassed everything we just talked about.
Exactly.
All of that encryption,
all that security,
and you're now speaking directly to the brain of the device.
Yeah, and that's always true. The more you get closer to the processor, to the electronic components, the less the security could be, simply because there are simpler and simpler mechanisms in here. So if that's not the case, but some cases we manage to connect directly to the processor, control it, or even change his firmware programmation, so you change everything of the device.
Absolutely,
So,
and it's good to see, again here, this is where your background in electronics and components and chips is every bit as important as your understanding of cybersecurity. In order for a product to be safe, we've got to look at the internet-facing side, we've got to look at the local communications, and we've also got to look at the device itself. We've seen how an attacker can hack into a device from anywhere in the world, or from right outside your house, or break into the device itself. And how here in the IoT Test Lab, we check that our clients' products have suitable controls in place to defend themselves against these kind of attacks. And it's this testing combined with an in-depth assessment on how that product has been specified, designed, sourced, manufactured, tested and supported. Those two things together combine to give suitable assurance for us to place our mark of trust, the Kite mark, on an IoT product that says this product will work safely, securely as it should throughout its intended life.